Hey everyone, today we are going to be learning about telescoping series, and what we don't get through on the handout today, you will then finish for homework. So the homework is to finish this worksheet. Okay, so there's a couple of things you need to know about before we get started. So the first thing is to review what a sequence is and then what a series is. So a sequence is a string of objects like numbers that follow a particular pattern. The individual elements in a sequence are called terms. So term one, term two, term three, sometimes we call them A1, A2, A3, etc. I believe in honors algebra 2 trig, you call them T1, T2. We have A1, A2. But examples would just be things like 2, 4, 6, 8. Okay. Another example might be a third, a ninth, 27th, okay, dot, dot, dot. So a sequence is a string of numbers. A series then is the sum of the sequence of infinite terms. Okay, so it's just adding up all the numbers together. So some examples would be to take the same terms that we have from the sequence and write them with addition signs in the middle. So 2 plus 4 plus 6 plus 8, dot, dot, dot. Okay, or a third plus a ninth plus a 27th, okay, dot, dot, dot. Sometimes we'll write them in um, what we call summation notation. So sometimes you'll see something written like this, or like this series over here. This series would be rewritten as 1/3 to the n, where n starts at 1 and goes to infinity. So if you remember, we did this earlier in the year, and that is literally what that series is. Okay, and we're going to be learning how to find the sum of more complicated series in this, but this is just a quick recap. Okay, so some of the things that we're interested in are what it means for something to be divergent versus convergent. And we want to talk about it both as a sequence as well as a series. So if a sequence is divergent, it just means that the terms of the sequence do not approach a value, okay? If we're talking about a series means that what we call partial sums of the series do not approach a value. Okay, so that's the definition of divergent, and then hopefully convergent will make sense when we say that if a sequence is convergent, then the terms of the sequence approach a value. And if a series is convergent, then what we call the partial sums of the series do approach a value. Okay, so those are kind of the general definitions. And now I'm going to show you some examples of convergent versus divergent series. Okay, and these should be on your paper. So here's an example of a convergent sequence. So the terms are a third, a half, a third, a fourth. So you can see the denominator is going up by 1. And these are each of the numbers that are getting smaller and smaller and smaller. So because they're getting smaller and smaller and smaller, they're approaching 0. So we would say that this sequence converges to 0. And here's some examples of other convergent sequences. The numbers keep getting smaller and smaller. Now these are actually, while they're going back and forth between positive and negative, each of the values are still getting closer to 0. The next one will be negative 1/16, then positive 1/32, and so forth. Now, a divergent sequence is usually pretty easy to see. It's growing infinitely large. So here's an example of the graph. So the values, the y values, keep getting infinitely larger. And you can see that here, the numbers just keep getting bigger and bigger and bigger. Bigger, bigger, and bigger for this one here. And this one, although they are going positive, negative, they're actually flipping back and forth and getting farther and farther away from the x-axis. Okay, so then here are some examples of convergent series. So a series is what happens when you add each of the terms together. So when you look at this problem here, and let me label this over here. So this is a half, and then this is 1. So when the first, what we call partial sum, is at my 0 term, and it's a half. So here's the half. And then my next value is when I take a half and I subtract a third. So a half minus a third gives me this y value here. So this would be my second partial sum. Well, now I'm going to add a fourth on. Here's my third partial sum. And then I add a fourth, or add a, can't talk, subtract a fifth, add a sixth, subtract a seventh, add an eighth. So the numbers keep going back and forth, up and down, but eventually you're going to see that the series converges, is it because it's approaching the value of 0, okay? Both of these will do the same thing. So if you were to keep adding the terms together, you'd see they'd be approaching a certain value. The sum is not approaching necessarily 0, but the numbers are getting closer. Divergent series then are when you just keep adding numbers on, it just keeps growing, growing, growing bigger. So the numbers keep making the series just grow, 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 grow. So see how it keeps getting larger. These just keep getting larger, larger, larger. And these are getting larger but negative, then larger, then more negative, then more positive, then more negative. So it's going to be said to be a divergent series. Okay, and I would like you to fill this in on your own. I'm not going to tell you what to write here, but I want you to think about what does it mean for a sequence to converge and what does it mean for a series to converge. So I already kind of told you, so I want you to think about what it would mean and write it in your own words. Take a moment, maybe pause the video if necessary, and then you can move on to the next page. Okay, so our big focus is going to be what's called a partial sum, which is literally the sum of part of a sequence of terms that are added together, okay? The first partial sum we'd say is S1, the second partial sum we'd say is S2, and so forth and so on, okay? So if I have, I guess I should probably tell you what the series is. I didn't really write that down here. Let's get a pen. Okay, so if I have the terms 2 plus 4 plus 6 plus dot, 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 okay? The first partial sum would be just, in this case, the first term. The second partial sum is what you get when you add the first two terms together. So that happens to be 6. The third partial sum is when you take the previous two, which is 6, and add on the third, which is also 6, and you get 12. So you can repeat this as many times as you need to till you see a pattern developing, or you come up with the pattern yourself, okay? So we are looking for the nth partial sum, which you may not remember this from earlier in the year. This was chapter 12 that we did at the end of first semester. There's a formula for what this is called an arithmetic sequence. Well, it's a series technically, and for finding the sum of the n terms of an arithmetic sequence, the formula is this: n over 2 times the first term plus the last term, okay? So what we really need to do is find this formula because I don't know how many n's there are, that's the point. I know the first term is 2, but I need to find a formula for the arithmetic sequence that'll go there. So it is really just an equation of a line. So the equation of this particular line, if you want to think of it as, the first term is 2, so it's like the point 1 comma 2, and the second term is 4, so it's like the point 2 comma 4, okay, if you want to think of it like this. Or you could think of this as the 0 term and the first term, whatever works for you, okay? So if I think of it like this, I get a slope of 2, okay? And then if I use this point of 1 comma 2, my n term is 1, and my a sub n term is 2. So I'm doing like point slope form of a line. Okay, I took the long way to get there, but if you understand how to just kind of look at it, hey, if n is 1, I get 2. If n is 2, I get 4. If n is 3, I get 6, and that's really just 2n, then you're in better shape. So this is kind of the beginning of the formula. So I want to write it out a little bit more simplified. So when I write this out simplified, I can either get n times n plus 1 or write it as n squared plus n, whatever is easier for you. Okay, so now we're going to talk about an infinite series. So in this case, I have this summation notation formula, and I want to figure out an expression for the nth partial sum, which means I usually need to find at least 3 partial sums. The directions here tell me to find 4. So I'm going to do this by substituting some terms in here, okay? So I'm going to put 1 in for n, because that's where it's telling me to start. So I get a half minus a third. That's my first partial sum. Do not do anything to that. Leave that alone. My second partial sum is the first partial sum plus the second term, which is a third minus a fourth. Okay, so hopefully what you notice is that these thirds cancel out. And this is where our term telescoping series comes from, because these little terms are canceling each other out. Okay, so I have a half minus a fourth. My next term then is a fourth minus a fifth. And my fourths cancel. And now my fourth partial sum, is a half minus a fifth plus a fifth minus a sixth. Okay, so I'm going to look at what I have left over and come up with a formula for the nth partial sum, which will not use like your arithmetic or geometric. Basically, I see that a half is always in the problem, so a half. And then I see that it's a sixth was left here, a fifth was left here, a fourth was left here, a third was left here. So I'm always left with 1 over n plus 2. So this is my formula for my nth partial sum. Okay, so we're going to use this process to find the limit, so to actually find the actual sum. So I'm going to show you another way to do this. So I'm going to find my fourth partial sum right away. Here's how you do it. So I'm going to start with substituting my first term in. So my first term is 1/4 minus 1/5. Okay. Then my second term is what I add on to get the second partial sum, and that is a fifth minus a sixth. And then my next term is a sixth minus a seventh. And then the next one is a seventh minus an eighth. And hopefully what you see happening here is the fifths are gone, the sixths are gone, the sevenths are gone. So my fourth partial sum is actually a fourth minus an eighth. So I want to use that information to find an nth partial sum, which will be a fourth minus, and I have to figure out, well, how did I get this 1/8 with a term of 4 down here? And that really is coming from the second part here. So it's over 1 or minus 1 over n plus 4. Okay, so then I want to use that s sub n to determine the limit, which is what we call the sum of the whole entire series, okay? So the sum is just going to be, or sorry, the limit of the sum is going to be, look carefully at what you have here, as n goes to infinity, this part goes to 0, which means I am just left with this first term, which is a fourth. So the answer to the limit is a fourth, okay? I'm going to leave this one to be part of your homework because I think you can do that one on your own, but we want to get started on this one to make sure you understand what's going on here. So this particular problem here, which says it's part of your homework, I think, no, yes, I guess it is. Okay, so this problem is at the top, and notice it is not written with fractions. So what we have to do, because there's not two fractions, is we actually have to do partial fraction decomposition, like we've been learning, to help us write it as two fractions so that I can figure out if it's telescoping or not. Okay, so my partial fraction decomposition will look like this. A over n plus b over n plus 1. And I get 1 equals an plus a plus bn. This one isn't too bad. You can see that a equals 1. And if a equals 1, and a plus b here and here will equal 0, so that means b equals a negative 1. Okay, so now I have the series 1 over n minus 1 over n plus 1. And so now you're going to find, it's up to you how many partial sums you need to find. I think you might be able to get away with doing it for 3. So this one was starting at, be careful where it starts. It starts with 1. So it'll be 1 minus a half plus a half minus a third plus a third minus a fourth. Okay, and you can see that these terms are canceling, which means my nth partial sum will just be 1 minus 1 over n plus 1, which means my limit as n goes to infinity of that is just equal to 1. Okay, I hope all of this made sense. Please feel free to pause the video as necessary. Pay close attention as you're doing your homework to where the value starts. So for instance, this one starts at 2. Okay, be careful of your factoring. So for instance, this one factors into 2n plus 1 and 2n minus 1. So be careful of that. And this one also, this one's okay, I think. But I feel like on your homework it says it starts at 3. I might be wrong. Oh no, that's okay. It's the one below it that starts at 3. Sorry. So the one that's 2 over n squared minus 2n, this thing starts at 3. So your partial sums, if you're looking for the first 3 partial sums, the value has to start at 3. Okay. I will have the answers available for you, so just make sure you go and look at them in case you have questions. See you on Monday.